Geotechnical Society Delhi Chapter, an Eminent Engineering Personality Award by Institution of Engineers Delhi Chapter are only some of the awards that he has received. Let's put our hands together once again for the moderator, Shri S.K. Nirmal. A very warm welcome to you, sir. Now, we would be inviting the session panelists to kindly please join us on the dais for this session, beginning with Professor Manoranjan Parida, Director CSIR, CRRI, to please join us. Zordar taliyan Professor Manoranjan ji ke liye. Can we have a louder applause, ladies and gentlemen? Known for his active contribution for the development of 1,700 kilometers of state highways and development of noise barrier for flyovers is a testament to his passion. Recipient of coveted positions such as the Deputy Director of IIT Roorkee and North Chair Professor, he is always keen to expand the deployment of state-of-art technologies for road development in the country. We welcome you, sir. Ladies and gentlemen, inviting Professor Dharamveer from IIT Mumbai to please join us on the dais. So, taliyan Professor Dharamveer ji ke liye. A leading pavement engineer, expert and professor with over 24 years of experience in teaching, consulting and research. Professor Singh has transformed road construction practices across India and beyond and has been honored with the prestigious Pandit Jawaharlal Nehru Birth Centenary Award. Please join hands once again for Professor Dharamveer from IIT Mumbai. We request Shri Bovin Kumar, CEO Cube Highways, who is a seasoned infrastructure leader with nearly 3 decades of experience, to please join us now. Please join hands for Shri Bovin Kumar. He is well known for being very passionate for innovation and technology to deliver exceptional service quality and operational excellence. He is widely respected for his commitment to sustainable infrastructure and enhancing user experiences. A wonderful warm welcome to you, sir. And ladies and gentlemen, last but not the least, may I please invite Mrs. Atasi Das, a pioneer in sustainable pavement engineering and assistant vice president at GR Infra Projects. With over 26 years of international and national experience, she's led innovations in highway design, earning accolades like the Vishwakarma Award for Women in Construction. Zordar taliyan inke liye bhi bahut bahut swagat. May I please invite Shri Mayank Tyagi to kindly welcome our wonderful panel with a token of appreciation for each one. Welcoming our moderator and the panelists. सबसे पहले आइए शुरुआत करते हैं, स्वागत करते हैं श्री एस के निर्मल जी का, our moderator for this session. बहुत बहुत अभिनंदन. Thank you very much for joining us in this session. Shri S.K. Nirmal, ladies and gentlemen, let's join our hands. A very warm welcome. Professor Manoranjan Parida, thank you very much for joining us here in this session. We would like to acknowledge the presence and also thank you for being here with us. A round of applause for Professor Manoranjan, Director of CSIR, CRRI. A very warm welcome once again. Now welcoming Professor Dharamveer from IIT Mumbai. बहुत बहुत अभिनंदन, स्वागत. Professor Dharamveer, बहुत बहुत अभिनंदन. A very warm welcome to you. Shri Bovin Kumar, thank you very much for joining us here. Shri Bovin, CEO, Cube Highways. A wonderful warm welcome to you. बहुत बहुत अभिनंदन. Welcoming Madam Atasi Das for joining us here, who's a pioneer in sustainable pavement engineering and assistant vice president at GR Infra Projects. A wonderful welcome to you, ma'am. Thank you very much for joining us here. And with this, ladies and gentlemen, very quickly, we would like to hand over the session to the moderator, Shri S.K. Nirmalji, and request him to kindly please begin the deliberations of the session from here. Sir. Shri S.K. Nirmalji.
Good afternoon, friends, ladies and gentlemen. This session, though it is just before the lunch, and already some time has been encroached by the previous session, so we will try to keep it in time as far as possible. As you all know that new and innovative material use and their use in quality control is getting highest importance from Ministry of Road Transport and Highways, NHEA and all implementing agencies. So before I develop this particular subject, I would like to give a little background how it all started. In fact, in 2005, when model concession agreements were being prepared for all the sectors, that Planning Commission, Finance Ministry, Road Transport Ministry and NHEA, that time it was being thought that let us give freedom to the BOT entrepreneurs so that they can bring new technology, new materials, and we get innovation in our road projects. And they are all BOT projects, so money is being spent by concessionaires, so there should be no problem in giving them freedom. So they also asked NHEA, in fact Indian Road Congress, that why don't you have a manual so that you only frame the broad parameters and other freedom can be given to the developer or concessionaire. So that time we started preparing this 2-lane manual first, and we made the enabling provisions, because unless there is a provision in the manual which is part of the contract, you cannot implement any technology or any material. So we made enabling provision, and then model concession agreement also was finalized and we rolled out. But what we found that ultimately our mindset was that only what is given in the DPR only should be implemented, nothing new should come. And that was from the fear of failure, not only in concessionaire but also from the authority side. The person who is preparing this document or person who is approving this document, they also had fear. So in fact the first decision about this issue, that how to address this issue, how to promote new technology, this first circular was issued by Ministry on 7th of June 2013. And on file, I took the approval from the Minister that if there will be any failure of any technology which we will implement under this particular program, there will be no punishment. So that approval was taken on file from the Minister, and then we started rolling out that a sort of accreditation committee was set up in Ministry. We will examine new materials, new technology, and we will approve them. And based on our approval, then they can be implemented in our contracts. First on trial basis, and then if their trials are successful, then on full scale basis. So after that, then a committee was also set up in Ministry, because they were finding that still people are not coming forward to implement the accredited material. That time in 2-3 years, we accredited about 22 materials in Ministry and we uploaded on website that anybody can use them, normal projects as well as BOT projects, but still we were finding that people were not coming forward. So there were a lot of such conferences from IRC side also, from and Ministry and NHEA, everybody was trying to promote in various conferences, but still we found that the mindset has not changed, basically. So in various forums, Honorable Minister was also very candid in accepting, yes, let us, even our secretary told in one of the conferences that I will punish those officers of NHEA or Ministry who are bottleneck for implementing this new technology. So to that extent, Ministry was very enthusiastic in bringing this new technology. And 14th of December 2020, first exhaustive circular was issued, where all the new materials, alternative materials, technologies, everything was very clearly given, and what are the reference point, which is the IRC code, and how it should be implemented. So that 14 December 2020 circular is explaining all these things in very great detail. And then still we found that these technologies are not being used. So then another, in August 2022, then another policy circular was issued where we explained that value engineering services which are normally being done in BOT projects by the concessionaire, why not to bring in DPR stage itself? Because unless it is in DPR, it will not be implemented. That is what we understood. So that exhaustive circular was issued. What are the options available in value engineering services? So that's after that circular, there were issue about saving, that if there is a saving, what should be done? So that also was addressed finally in September 24. I think if you go through the last circular of Ministry, September 24, everything has been explained about this, what options could be given to the consultant, contractors, concessionaires, what freedom can be given, because we were finding that some freedoms are being misused also. So that is being a hurdle in implementing of new technology. So with this kind of framework now in place, now I think the last circular is addressing almost all the concerns of government side also. So there should be no problem, and in fact this panel discussion today, we will like to hear the experience of all the expert panelists. We have panelists from the research institute who are promoting this technology, who are developing this technology. We have from academic institutes who are also in part of, spreading and capacity building. Then we have one from the contractor side, one of the leading contractor representative, and then concessionaire representative also is there. So without taking much time, I think we will hear from the expert panelist in the course of this particular session. Thank you. So first, I think Professor Manoranjan Parida, you can give your views about this and presentation.
Thank you very much. Good afternoon, everyone. So it's a great privilege to share the new technologies in which CSR, Central Road Research Institute, has been working. So I have tried to make a very brief presentation. I will not go into the detailed presentations, but some of these technologies in various forums we have already shared, but this is a great opportunity to provide a very quick overview. On many occasions, we have been quite fortunate that some of the NHEA officials, MORTS officials, they have been very much part of these technology trials, those which has been tried on the ground. So I start with the steel slag technology, which has been used for road construction. So this is one particular technology. The basic idea is that substitution of natural aggregates. Natural aggregates are going to be very scarce kind of resources. In the previous session, there was a discussion that you have to build another 2 million kilometer of road network. You have to maintain the 6.3 kilometer of road network which has been created. So we cannot do the business the routine way we are doing. So the steel slag based road construction provides opportunity that the processed steel slag can be a substitute of the natural aggregates. And in terms of the steel slag which is produced from the various steel industries, currently it is 9.5 millions, and by the end of this decade, it is exactly going to be doubled. So already we have done the trial. This is one example near Surat. So it's a 6-lane facility in which the steel slag has been utilized in all layers for the flexible pavement construction. So this is one example of NH66 from Mumbai to Goa. In fact, we have done it in association with the NHI, where the steel slag has been utilized both for construction of cement concrete roads and bituminous roads, and in all layers the steel slag has completely replaced the natural aggregates. So this is another example of trial at Arunachal Pradesh near Zero Valley. So this was basically for the design of the overlays. It was for a 40 millimeter BC overlay. The steel slag was used, and this project has been possible because of the sponsorship from Ministry of Steel which was done in association with AMNS, with Tata Steel, JSW Steel and RINL. So, it has received attention of Honorable Prime Minister because the project is being pursued under the mission Waste to Wealth, so which gives a specific mandate of using the various industrial waste for construction of road infrastructure. So, I am not going into the details of it, but then the steel slag guidelines has been prepared by Ministry of Steel, which has been disseminated to MORTH, and currently it has also been under consideration of H2 Committee of Indian Roads Congress, because at the end we are expecting that we have a IRC document on the basis of that it is possible to scale up its application. The second is the replacement of the bitumen. So, this is one idea, the idea of biobinders from agricultural waste. So, currently we have a project which is sponsored by Ministry of Road Transport and Highways. CRI has a patent where it is possible to do a replacement of 10 to 20% of this bitumen by the bio oil. So, that is going to be produced from the rice straw. Because of the parali burning, this problem has been taken up, and CSR Central Road Research Institute in association with IIP Dehradun, this technology has been developed, and we did a trial at Jorbat between Guwahati and Shillong, and the other trial in fact it is slightly different from the earlier process. So, that was a bio oil based biobitumen, but this is one from the lignin, and we did trials with 15% replacement and 10% replacement. So, currently we are doing a finishing testing waiting with the Indian Oil. So, Honorable Minister has reviewed the whole activity. 1 kilometer of trial has been done near Nagpur, and we have been asked to put up the detailed specifications and standards of these lignin based biobitumen. So, that can be utilized for the road construction. Little bit about the cold mix technologies. So, in fact, if we make a comparison, the cold mix versus hot mix, although this is for the rural roads. So, you say in terms of fuel, for a cold mix construction, it is 90 liters of fuel. For the same reference, for a hot mix, it is going to be 1698 say liters of fuel. So, in terms of carbon emissions, the cold mix is going to be very effective, but in terms of practice, although in a lower category network it has been very effectively utilized, but we are yet to see its application with respect to higher categories. So, this is one mobile cold mixer cum paver we have developed and transferred to BRO. In fact, the technologies can be used in hilly areas. Currently, the equipment is there in Himachal Pradesh. So, for different projects of BRO, it has been deployed. So, NHEA DCL can take benefit of this. So, this is like the road which has been constructed using this mobile cold mixer cum paver. So, that basically addresses the challenge of space limitation to set up a plant through a mobile mixer. You can do that paving work. The institute is working on usage of waste plastics for road constructions. There are 3 patents with respect to the wet method of mixing, and currently we are working with one particular agency, Alliance to End Plastic Waste. So, here there is great opportunity of utilizing the plastic waste for bituminous mix road construction. There are certain other technologies which is been developed by the institute. So, this is one which is used for pothole repair. Very recently we did a demonstration with the government of Delhi to the PWD minister. So, this is like without dewatering, how do you repair the pothole, and the technology has been means we have entered into agreement with the government of Assam and in discussion with the government of Karnataka for wide applications of these technologies. Like currently cold emulsion based mixes are being utilized for the pothole repair. So, this is an alternate again, like it uses the cold process only. The other technology which has been which is there under discussion. So, this is the EcoFix. So, as an institute we have the mandate for developing the technology, transferring to the industry. Then the ideas of recycling, currently we have a limit of say only 30% of the RAP can be utilized, but can we go for higher RAP? So with NHEA support, we are doing projects with higher RAP content, because again the idea is that means recycling, reusing the material which is there as part of the highway cross sections. So the field trials are on with 35%, 40% and 45% RAP, and in fact on the basis of like the performance results, it is possible to make revisions in the IRC document where we have a benchmark of 30%. CRI has another technology which is residue technology and very successfully used by BRO. Currently even we have done a trial in Bhutan. So that is essentially to work with lower temperature and also in terms of using recycled material. So this is like in very high altitude areas, very effectively the technology has been utilized. So this is one more rejuvenator. The institute has a lot of interest in terms of various rejuvenating agents. So this is a rejuvenate technology which is transferred by from CRI to the WUMS industry, and this is also a potential material that can be very useful in terms of recycling of bituminous pavements. So I will just conclude with this. I'm really grateful to the support of Ministry to NHI in terms of trial sections, but the limitations are that the ideas need to be scaled up. Already Sri Nirmal has pointed about the challenges, because today if you look at the trial patches, they will not cross triple digit. It is less than 100 kilometers, and in certain cases the concessionaire, although they are utilizing, in some cases they are not being reported. So these forums, they provide a great opportunity where we can share our experiences, especially the steel slag has been utilized by a lot of concessionaire, and the disseminations is certainly going to help the sector in a very big way. And I believe that the various technologies, it takes time. Many times the industry expects that you provide a ready-made technology, so it is never available on the shelf. I urge the industry to be a partner in the development process, the way we are getting trial sections of NHI or MORTH, because the co-development is only possible. You can't expect a finished product, but then these technologies, they have a great potential when we look at the future of highway infrastructure development in the country. So thank you very much for this opportunity. Thank you.
Thank you, Professor Parida, for explaining about various new technologies which are in development phase, and what do you expect from, there is a code requirement for steel slag to promote further and bring confidence in the users. So I think the challenge also is that more and more trial stages if we give, then we get more confidence. That is also very important for the authorities. Thank you. Now Professor Dharamveer, I think we can hear from him. He is educating, he is involved in capacity development and a lot of, I see his web messages very frequently. So he is very actively involved in promoting new technology.
Very good afternoon to all of you. Looks like you all are tired. So the lunch time is there. We'll try to close it maybe before it starts. I will just take 10 minutes. And presentation is quite straightforward. And many of the things you already know. I will just highlight the points. I am not going to criticize the thing, but I will just try to bring the focus on why we are not able to do something when we have the tools and techniques with us actually. And that is how the focus of this particular presentation. I will show you this photograph. अगर आप इस फोटो को देखेंगे, एक तरफ बिटमिस रोड, एक तरफ कंक्रीट रोड है. आप अगर आप थिकनेस देखेंगे बिटमिस रोड का, देखिए ऑलमोस्ट 320-330 के लगभग थिकनेस है बिटमिस रोड का. In spite of that, there are failures. डिजाइन का इशू तो नहीं है, या फिर कंक्रीट का मटेरियल का इशू है, कंस्ट्रक्शन का इशू है, वी हैव टू लुक इनटू दैट एक्चुअली. And when somebody is designing, because design is also very important. So in this particular case, thickness has been designed, but whether the combinations were right or not, that we have to think about it actually. दूसरी तरफ आप देखेंगे तो कंक्रीट का रोड है, and we'll just keep on looking into certain photographs. आप फोटोग्राफ देखेंगे, कुछ certain roads you are going to see rutting very fast. हो सकता है maybe within 1 year, हो सकता है within 2 years, or maybe the very quick. Cracks भी हैं, potholes भी हैं. And if you see the interestingly one photograph which has very beautiful pattern of the potholes. And on that particular highways, because I remember I was part of that particular project, the thickness of the bituminous layer was almost 300 mm. अब 300 mm का thickness है, definitely bitumen, you cannot blame subgrade now actually. In spite of having very good thickness, the potholes were there. In fact, cracks are also there if you can see on the photographs. And bridge deck has become another issue because the selection of the mixes for the bridge decks, waterproofing membrane kya hai, how do we select it, how do we lay it down, what kind of quality test do we do on that, and what kind of mixes that we have to select. I think very much little attention has been paid on that. And because of that, if you see a lot of failures on the bridge decks, you are going to see on many places actually. Yeah. So this is how the way forward now. You do the pavement evaluation, rehabilitation, preservation or innovation. And we are not going to discuss everything here. I will just touch upon critical points, what exactly we are doing on different spheres actually right now. If you see this particular lifeline of the pavement starts very good in the beginning. If you see the point here, it starts very good on the excellent conditions and then gradually deteriorates actually. Quite possible for some of the pavement, this graph may not look like that. It may be very fast, it may come down very quickly, quite possible. It may come like this, possible, or some of the pavement it may go like that also. For that, you need to understand what kind of pavement condition we have to understand, how do we deploy the techniques to improve this particular graph, deterioration graph. And there are IRC 82 is there, 2023, and it recommends that pavement conditioning index has to be determined or it has to be quantified for particular pavement section. And it has certain parameters. It has the riding quality, potholes, rut depth, cracks, raveling, and you just do all kind of distress measurements, and based on that you just do the PCI index. And based on the PCI index, you determine the what kind of treatment is to be required for that particular highways actually. On some of the instances we have seen overlay is not required, but overlay has to be put up because of the contractual conditions, or sometimes the debate comes whether microsurfacing can do the job or BC is not required actually. So that kind of debate comes. In fact, right now a lot of advancement has come in this area. We are going to talk about that also actually. There are certain, you can see the techniques for O&M, and I will show some critical examples later on. Either you can use the microsurfacing or thin overlays, or you can use some innovative combinations of the recyclings. I will show you some of the examples and where we are really hitting the points and where we are heading actually. There are certain kind of improvement is also there in this direction. People are talking in terms of you construct something, some overlay, and it's something, nothing should happen at least next 10 years. New additives have come, polymers have come, modified binders have come, hybrid CRMB have come, waste plastic is also coming up. So we have to definitely innovate that. In spite of that, there are certain failures are coming up because of the concerns somewhere else actually that we have to also address. Some paving practices also we have to improve upon actually. We keep on talking about the materials, we keep on talking about the designs, we keep on talking about but how about the paving practices? Who is going to construct the roads? In fact, in the morning we have been listening that where are the engineers actually? Who is going to construct the road? What kind of education that we can transfer to the ground people actually, so that they can execute the things better. And this is what we need to understand. Technology is not going to help you. You have to really adapt the technology to bring the quality outcomes from that actually. And this is one of the project that we have done in one of the National Highway project, and thank you to Ministry and National Highway for giving us that particular trial stretch. The debate was quite simple. BC2 mix, if you say the minimum bitumen content is 5.4%. On one particular project, the aggregate quality was quite good, and contractor was quite sure that if I use 5.4% bitumen, it is going to bleed out actually. However, how do I prove that we cannot use 5.4 actually? On that particular project, what we have done, we have constructed almost 4 kilometers of the stretch using the performance-based design approach actually. We have demonstrated that if you do the construction using 5.4% bitumen content on that particular project, depending upon the quality of the aggregates and all, quite possible you may see certain failures. We did cracking test, we did rutting test. Based on that, we have optimized the bitumen content. And remember that it is not like cut and paste formula everywhere actually. You have to really be very careful that what kind of aggregates are there, what kind of properties are there actually. And you can do the rutting test also. In fact, I will go very fast in that. And this test is becoming quite popular nowadays because a major concern for us is the rutting nowadays actually. And that can be trapped actually. If you are smart enough in the beginning of your project, in beginning of the production of the mix, and there itself you have to check. And sorry to say that many of the mix design that I have seen so far, and whatever it has been put up in the plant, it's all like done in a few days actually. And it's very simple. You put aggregate, you put bitumen, and you know 5.4, 5.0 aggregates are there. That's it. That is the mix design. But that's not the mix design actually. You have to also execute that. You have to validate that in the plant actually. This is how the sample look like. Different mix will behave differently. In fact, we have developed certain tool. In fact, in morning you see we got certain kind of certificate. It was based on certain simple tool that we are developing now actually for the industry. And hopefully I think that will work out in the future. This is another technique that is coming up nowadays, and CGBM, which is called cement grafted bituminous macadam. 1 or 2 project has been done. In fact, we are also deploying that particular technology. It sounds to be good on certain stretch where you have the critical problems. So this is what it's coming up now. I will just go over now in these tools actually. Network survey vehicles have been used quite frequently on the highways, and you record all kind of distresses. There are different kind of distresses that you record. This is how the riding quality look like. Look into the riding quality now actually here. The riding quality requirement what we have as per our IRC specification guidelines and whatever the IRC, US or other country actually have. If you see this particular graph, the riding quality on this particular highways, it goes abnormally high actually. And this is same case for the concrete road, same case for the bituminous road also. Not for all of the road, but majority of some of the roads are behaving that kind of abnormal actually. What are the regions? How do I take care actually? Some debate is also going on. Do I need to do the riding quality using NFC or BI actually? I think we should not go into that debate anymore actually. Because the advanced tool have come up. They are more accurate, they are more mechanistic, fundamentally strong. We cannot rely on the bump indicator, which is a response-based system actually. And so we have to think about that. One of the client or one of the contractor, he started debating on this particular photographs. Sir, NSV is giving you more riding, higher roughness index, but bump indicator is giving less. In my contract, bump indicator written, therefore I will accept bump indicator only actually. I said riding quality is a riding quality actually. And you are collecting the data from certain tool actually. And there is a fundamental strong background behind NSV, how the NSV collect the data. But this is how the debate is going on now actually. Rutting also it can be measured like that. Now the falling weight deflectometer, if you see, a lot of questions in the industry on the falling weight deflectometer. I will show you some of the example, very interesting example that how the contractor and agencies are really fighting their head on that actually. What is happening? Purpose of falling weight deflectometer is very simple. Do the structural evaluation, design the overlay actually. And if you see this particular, this is how the background goes actually. I will not go into the background, I will go to the main crux of this actually. Look into this particular diagram carefully. The blue indicate the aggregate modulus and the orange color indicate the subgrade modulus. Majority of the places subgrade modulus is less than the aggregate modulus is less than the subgrade modulus. How is it possible? You have 450 mm thickness of aggregate and subgrade is there. How is it possible? But this kind of report has been submitted, approved, and now think about the consequences of this kind of data actually. The overlay thickness will go 100 mm, 120 mm. There has to be some logical concept behind that why it is happening. Either by now the payment should collapse actually, if that kind of situation is there. Now if you see this, we corrected that particular problem because FWD, one FWD can give different results than other FWD because all are doing different ways actually. Yeah. So this is, some people call it as black box. If you see this particular overlay thickness which is designed earlier, and if you really pay attention on the data and you look into the data carefully that how the analysis has been done, what kind of tool has been used, you will find the difference actually. And these are the actual project data I am showing you actually. Earlier the thickness was 80 mm, we repeat the FWD, do it again, the thickness has come 450 mm, measured of the places. Now that becomes the topic of debate that why this FWD was initially wrong but now it is correct. It is not wrong and correct, it is the way that we are doing the analysis actually, the way we are looking into the data. Until unless the consultant or those who are doing this particular survey, they are aware about it, same mistakes will keep on going actually. You will be putting unnecessarily 50% more. Now comes the milling and overlays. It's very common job nowadays actually. In fact, we have seen the brand new roads are getting milled and then overlay has been put up actually. Now another thing has come up, glass grid. And there is a lot of claim that glass grid, you put the glass grid below BC layer, the life is go 10 years. In fact, one of the major highways connecting from Mumbai to Jaipur, if you visit that, you will see a lot of slippage failure actually, almost more than 30 to 40 kilometers. Lot of failures have come up actually. How do I take care actually? What kind of design do I do? What kind of precaution that I need to take up actually? And this is how we need to look into that. See, the quality has to be achieved once you understand the kind of technologies, how it has to be implemented properly. Another comes the white topping actually. It's very popular. In fact, Maharashtra is leading in that particular area and a lot of good work is going on actually now. The question here is, how do I understand the bonding, debonding, how do I understand the performance of the white toppings actually? The failure comes, why the failure comes actually? What is the role of the bituminous layer in that actually? This is what we need to really look into that at this particular point of time, otherwise it will be too late for us actually later on in the future. Lot of distresses, lot of repairs, and I have seen the different practices of doing repairs of the concrete pavements actually. Somebody is innovating themselves, somebody is doing their own understanding, somebody is doing stitching in their own ways, somebody is doing stapling in their own ways, different practices are going on actually. Many agencies, they all are doing different work actually. But the concept is same, failure is same actually. Other interesting thing is the construction, the quality of, the riding quality of the concrete pavement. You see one of the example. Concrete pavement riding quality, the index has to be 2000 less, but this is how it looked like. It is 4000, 5000, in fact more actually. The question comes, how do I improve that actually? Either I can use micro milling, or I can use the diamond grinding, or I can use asphalt overlays, or I can use micro surfacing. Something has to be done. The riding quality, you cannot reconstruct your highways and then do it again. And what is the guarantee that reconstruction will help you? Again you will come back to the same. So some of the things are there actually. Bituminous overlay, in one of the projects we have done the bituminous overlay using certain kind of different mix design approach, and we found it quite interesting and quite kind of, you can see the positive outcomes. However, we have to take care the kind of joints, the kind of cracks, they are there on the concrete pavement, other reflective cracks will come up. So this is what we are supposed to look into that actually, this is one of the solution. But recently the ministry has issued circular that you cannot put BT overlay on top of the concrete actually. We need to look into that actually, because this is quite popular in all over the world actually. Other thing is the micro surfacing, don't waste your money on that. One layer is not going to help you anything actually. If you are putting 6 mm micro surfacing on concrete pavement and assuming that the riding quality will improve substantially, it will not happen actually. You need to think something bare minimum at least 30 mm to improve the riding quality actually. But then you can think about 3 layers of micro surfacing or 4 layers of micro surfacing. So this is one of the projects that you can look into that actually.
Just 2 minutes please.
This is how it was last 2 slides. This is how the micro surfacing look like. Another thing which is coming up now is the micro cold fine milling actually. Some of the project has been done in this particular area, that how do I do that fine micro milling, whether it is a really right approach or not, that we have to discuss. It will definitely cut out something and improve the riding quality. And if you see here, this is how the sum result look like. The red color is the before and the green color is after doing the fine micro milling. There is certain improvement. However, there are certain concerns also that we have to look into actually. The aggregate exposed, the skidding, the friction, all kind of things that we have to also look into that actually. Another approach is diamond grinding, which we don't have any equipment right now in India for doing the diamond grinding and grooving. Definitely some small scale grooving equipment may be there, but diamond grinding is altogether different equipment. If you see the photograph on this side, this is how the diamond grinding, this equipment look like. Almost more than 200 blades in one drum, which is going to travel together actually. This is how the rehabilitation of concrete pavement is rubblization. Rubblization is quite, I mean, very popular in some countries. In fact, in US, they do a lot of rubblization because the concrete pavement is completely out of repair boundaries. You have to think about rubblization, and that particular layer can become your aggregate base. But you have to use the proper rubblization technique. I'm not sure whether it has been, one of the project it was done on airport, but not on the highways. I'm not aware about that, but this is one of the technique that you can think. Many project has been done in other countries actually. In fact, in the US you see a lot of project has been done. And this is the photograph that you can see on the rubblize project actually. And this is what the last slide for me. Any technology development that you planning to adopt, please understand the technology, get the technical support, train your team, have the quality monitoring, accept it, get the feedback from the data, from the field. Technology is not the substitute for poor paving practices. If your team is not good to adopt the technology, it doesn't mean the technology is going to help you actually. So with that, I will just conclude my presentation. Thank you very much.
Thank you, Professor Gambhir, for bringing various options for the maintenance and rehabilitation of various pavements and all the technology available for that. Next presentation from Ms. Atasi Das. She will be talking about implementation because they are directly implementing a number of technologies, and let us have their experience.
Good afternoon, everyone. I will be discussing some of the technologies that we have been using, the successes and failures, and also the getting successes by by improving on the technologies. So some of it will be talking on the bonded rigid pavement, some of the technologies of concrete and then flexible. And reinforced arch structures, repair and retrofits, because we see a lot of bulging and all, intelligent grading, and of course last but not the least, capacity building and skill development. Bonded rigid pavement has been in the IRC 58 code since a long time, but we have not used it. There is a little bit of distinct difference between the conventional rigid pavement and the bonded rigid pavement. We may think that there is an apparent saving. The bonded rigid pavement, when designed, the PQC thickness comes out at 240 mm. And the conventional is like 300 mm. And in this case, the PQC and the DLC is like monolithically connected together by virtue of mechanical bonding. We may do material bonding or mechanical bonding, but we have found success with mechanical bonding only. And now we have constructed hundreds of kilometers of bonded rigid pavement in the states of UP and Bihar. And also, it has heavily traffic corridor. And these are heavily traffic corridor, and the IRC code has been prepared under the RK Jain sir's supervision and all. It is going to be published soon. The execution and the quality aspects, the preparation after the preparation of the GSB, when we are constructing the DLC, the strength parameter has to be like 15 MPa. We are keeping a little bit of higher strength, and paving has to be done in one go for the entire carriageway width. If it is not possible, then we have to map the joints. The essence of bonded rigid pavement that we have to do, mapping of joints in DLC in the same places and the vertical plane that it has to be on the upcoming PQC. And also we have to seal the joints. And until and unless these quality aspects are not maintained, then it is not easy to adopt a bonded rigid pavement. We can only adopt bonded rigid pavement when we are quite sure of if we can do it. PQC has to be laid within 21 days of DLC laying. and the mapping of joints has to be done, and the joint cutting location using line dory and rate pen, all meticulous quality aspects have to be followed. The bond strength between the PQC and the DLC has to be maintained minimum 1.32 MPa, and every time and now we have to check by extracting cores. The challenges are that if the joints do not fall in the same place, then we will have entire longitudinal joint across the project corridor, and that is what we don't want. So those are the challenges in quality control. If we want to adopt any new technology, we have to also embrace the quality system. A little bit of cost comparison on the part is that there will be about 5 to 10% saving again, but there will be additional load of like joint cutting and sealing of the DLC, and so the saving, though apparent, it does not happen that much. Snapshots of the constructed bonded rigid pavement and heavy traffic corridor is going on, and from the core you won't find any distinction between the M40 grade of concrete and the M15 grade of concrete. There is no distinction at all. So it is so meticulously constructed with mechanical bonding by virtue of texturing. Coming to the short panel concrete pavement, well, we have done a trial patch of about a kilometer, again heavily traffic corridor in the state of Chhattisgarh. Again, it may be apparent that when we are reducing the slab size from 4.5 meter by 3.5 meter to 1.5 a square slab, it may be with the thickness reducing to 240 mm, it may apparently look like a saving, but no. There won't be need of dowel bars or tie bars, only required at the expansion and construction joints. It's very easy for maintenance and lesser thickness to handle. And now the quality aspect, we have to maintain 6 to 7 joint cutting machines on the same day, because otherwise if the joint cutting machines are not there, it is not worth to take up SSCP, the short panel concrete pavement at all. And we have to start cutting joint in bigger size like 3 mm by 3 meter by 3 meter, and thereafter coming inner 1.5 meter by 1.5 meter. So that is the quality aspect for making this technology a success. So these are again nice pictures. Mr. Yash Pandey from my team is there. He executed the work, and it is heavy traffic is like plying on the corridor with success. And again a little bit of cost comparison, there will be about 10% saving, but the joint cutting thing we have to embrace it, otherwise it won't be a success. Coming to sweet pavement, performance as sweet as its name. What is it? Under the leadership of Professor Nikhil Sabu of IIT Roorkee, we have implemented use of biobitumen or molasses in bituminous wearing cores. The molasses is again the quality aspect that it has to be followed in this case, the mixing, and there will be the mixing of when the molasses are mixed, that bitumen should not be heated more than 110 degrees centigrade, and the shearing rate will be 500 RPM, mixing time 15 to 20 minutes. But what is happening is that there will be some plant changes required. Unless we have a little bit of upgradation, a little bit of investment, and we can make this molasses a success, the biobitumen a success. And the biobitumen, the pumping the bitumen at the temperature should not be done more than at 150 degrees centigrade. And the blend should be used on the same day, should be mixed and produced on the same day it has been prepared, because prolonged heating may result in Maillard reaction, and excessive heating has to be required, and foams and fumes come out when we are mixing the molasses with the virgin bitumen. We have used VG40 and mixed the molasses in VG40 bitumen, and the plant will run at 80% capacity. We have to assume a little bit of glimpse of what we constructed, and again the traffic corridor is like 215 MSA. And this was laid at night time, so we can see a little bit of fumes coming out. So this is during construction, Shamli Muzaffarnagar area, just after construction, then after 1 year of construction, then after 2 years of construction. And the thing is that, I mean, there is no rutting, there is no cracking, nothing. And so biobitumen, can it be termed as a modified bitumen? With this heavily traffic corridor 215 MSA and using VG40 and replacing 25% of VG40 with the molasses, there will be a direct saving. and then our dependency on importing of bitumen will reduce, and we can it will be a smart way of working with the waste materials also. We can term it easily as modified bitumen. Future work is going on because we are going to use in our next project, we are trying to mix with wrap bitumen also, and lay molasses, wrap bitumen, and use in DBM also. So, a little bit of cost comparison, 50 rupees per kg VD40 bitumen, cost of molasses, it is 15 rupees per kg, including transportation we have seen in some areas. Saving per ton of bitumen is 35 rupees neat, it shows, but when we are replacing 25% is the recommended dosage, so there will be per ton, the share will be a 350 rupees of saving. We can implement it with some care of the plant modification. Coming to perpetual pavement, lifetime, lifelong. These are the compositions of the perpetual pavement that we have seen implemented in India. Many of them have seen successes and some we are having issues. Nevertheless, these are all with virgin materials, and the virgin materials like for greenfield corridors, but can we think of perpetual pavement in the brownfield corridors also? Of course, and it can be with or without recycled materials also. It can be done with FBBC, foam bituminous base course. Like we have 3 layers of DBM. The bottom layer can be replaced with a cold mix, where we will do the foam bituminous base course, and it will serve as a part of the perpetual pavement system. So, what will happen, this reduction in fuel consumption, we have seen already how the cold mix works wonders. Reduction in the use of virgin aggregates, lower bitumen consumption, utilization of RAP in the brownfield projects. The quality aspect that is required to handle with this FBBC perpetual pavement is of course zero error in quality. The construction of the subsequent layer can be done after evaporation of at least 50% of the water has taken place. The pros and challenges, it is that there will be a direct saving of virgin bitumen 2%, it is environment friendly, but the foaming attachment will be there. That investment has to be done. This project we are going to employ in our upcoming project, Kolkata-Varanasi Expressway. Reinforced start structures, repairs and retrofits. We know that, this is an unwanted case. Sometimes, unintentionally something happens due to quality lapses, and mostly in case of like RE walls which are constructed in like acute corners, because there will be complex fixing of geogrid at acute corner, then compaction is not possible in those areas, then selection of inappropriate fill material will be there, but we have all kinds of box structures, LVUPs, SVUPs constructed across our highways. So, what happens is that mitigation of quality lapses at acute corners, as part of mitigation what we do is that we do a lot of nailing. Nailing, it ensures the stability of the RE system, then we monitor also during the DLP period that no further movement is there. But what happens is that aesthetics is hampered due to the presence of service road and people commuting, and there is always people takes a photograph and puts it on newspaper. So, what we did that after the nailing work is done, we constructed lagging wall in front of the RE wall within the limited space, because we do not have enough space also, the service road is there. So, this is a scheme that works. Instead we can forego nailing also, we can forego nailing and construct such a lagging wall in front of the RE wall, so that it takes care of the bulging. It is anchored to the main system, to the parent system. The foundation system is like piles, it is on pile foundation, 600 mm thickness only. The length of the anchoring nail is 12 meter, placed at 2 meter center to center. Only the space requirement is only 2.5 meter. And the costing is also only 1.5 meter to 1.8 lakh per running meter as per the height of the wall. So, this is how it is constructed, the lagging wall. We have seen that how the nailing was looking in a bad shape and all. So, the pile foundations are done, and the step by step the wall is constructed, and now in the last picture we can see how stable it looks and gives a good feeling to the to the commuters also, it is stable and there is nothing going on regarding the stability of the wall. Now, coming to the case study 2, it is on the hill road. What happened that maintenance, again a quality lapse. The site team took up maintenance work during the peak monsoon season, and during the peak monsoon season, removing the paving, the bituminous material was not a good idea. and then came the incessant rainfall. So, this 2-tier RE wall, which is 26 meter high, so it bulged, and we can see the first tier, we can see the second tier. How to repair? So, these are the nailing, this is the scheme done, and Terre Army helped us with this, and the bottom tier wall was excessively nailed. I mean, it is not a worth of an idea to remove the entire RE wall system, which is like 26 meter high. So, what we did, we nailed the entire system, the panel system in the bottom wall, and then the second tier and the first tier we jacketed. The jacketing was done by virtue of like 2 meter height steel welded wire mesh panels, and then doing the infill with the crushed stone. So,
Just
first
2 minutes,
tier
please.
and first tier and bottom tier we have, now it looks a stable system. So, on the left side we see what it was, and on the right side we see what it is. Now, it has become, and no one will be able to see from from this figure ki there the panels, the defective panels are behind the new fascia. So, intelligent है सबके सब. The intelligent automation in construction, talking about intelligent grading, we also adopted in few of our project. Like we anticipated like it will finish on time, elimination of guesswork and rework, accurate and fast, real time monitoring will be done, precise control over each blade of grader and all will happen. Nowadays the RFPs, all the project RFPs are having the provision of intelligent grading and intelligent compaction, like equipment equipped with instrumentation, thermal sensors for bituminous work and GPS, everything real time compaction, real time feedback, everything will come. But no, it does not happen. 1 or 2 days our supervisors and the graders and the operators worked, the next day they gave up. No one is willing to do. So, what is that? Need to understand detail in the Indian condition. These are costly affairs and require skilled manpower to understand equipment and interpret the system. The capacity building is required. So, I mean in lieu of conventional system, if we one fine day, if we say that all projects to have intelligent grading and all things intelligent, it does not happen. So, capacity building and retaining labor is the next thing that we as contractors we are facing. The role of the government, industry and academia should this is a broader platform where we can discuss how we can bring up the initiatives, like when we are bringing in new technology, they are getting trained and something that skilled workforce should be retained and all, and what we can do, compensation and benefits can be given, and continuous learning and professional development can be given, and the child education, family stay can be accommodated in this at site level also only, that we are thinking of as contractors. So, that is all from my side. Thank you.
Thank you, Ms. Atashi, for bringing all the real implementation of all the new technologies and their challenges. Now, the last panelist, Mr. Bovin, I think you can share your experience of real new technologies by Cube Highways.
Good afternoon, everyone. So, my presentation is a bit different. I would not be talking much about materials and things, but I would like to start, with as we are concessionaire and investors into road sector. So, we generally either buy the projects from the existing concessions or getting the projects from NHEA as a TOT. So, basically we do not construct ourselves, but we get the projects which are constructed by somebody else, and these projects come to us with some issues. So, the first thing which I would like to speak about is now we talk about digitalization and data everywhere, but this is one thing which I feel we are still lacking on the data front. So, when we get any asset, we do not get design data, we do not get construction records, we do not get as-built drawings, sometimes we get, but not always. So, there are challenges, most of the time we face challenges with this. Secondly, on the maintenance front, we see some premature failures and issues in the pavement, we see poor quality of structures, and we see poor drainage, especially in urban areas. So, these are a couple of things which I am just highlighting, there are many more, so I am just talking about this. On the construction front, we do not do directly construction, but sometimes as a part of CA, if we have to do something, maybe some CUS work or some initial works, or sometimes as in one case we had to do 6 laning, so then we get it done. So I'll just highlight a couple of issues amongst the, our first project was Jaipur Mahua. So when we took over that asset, we saw a lot of rutting and premature failure on the right carriageway. So we investigated why it's happening. So one thing which we could find out was like, so there was a lot of marble carrying truck traffic. So overloading was one of the main culprit. Another thing was like the temperature ranges. So ambient temperature there was around 47, 48 degrees, leading to pavement temperature in the range of 70, 75 degrees. And in the winter it goes down. So what we needed was so when we had to do the overlay, so what we needed was a rut resistant material. So we did a lot of research and we then did test sections around 50 kilometers of HIMA, SMA and PMB and monitored the progress and worked well. So it's necessity is the mother of invention. So we had to explore, how do we deal with the issues. So we came out with this new material HIMA. Another issue which I would like to share was Delhi Agra section when we acquired. So there was one VUP and we were seeing that in the approaches there was failure time and again. So we tried to find out why it's failing, and when we do some trial pits we found that there is water ingress in the granular layers. So how do we address that? So then what we did is that we milled all the pavement, and first we had put the subsurface drainage system. So because we saw the geometrics of that road, so we said there's issue with geometrics and water is bound to come. So then we had to address that water. How do we take it out of the pavement? So then we had set up the subsurface drainage system to address, and now it has been already 3 years. We never faced any challenge in that section again. Another road, Ghaziabad Aligarh section, when we took over that section, so we observed that the entire pavement we had to mill. So now challenge in front of us was when we are milling around 90 kilometers of 4-lane road, what do we do with this milled material? So then we explored various options, and that's when we decided to go for cold central plant recycling, and we saved around 425,000 metric tons of aggregates and significant bitumen as well. So it was environment friendly, we saved some cost also. So that's how we addressed a couple of these challenges. Similar challenges we see on the structures. So when you see any RE walls constructed maybe 20-25 years before, you will see them still intact, but as Secretary Sahab was saying in the morning, with speed probably we have somewhere lost quality in some cases. So but in RE walls it looks very frequent that most of the RE walls you will find bulging. So that has become like a norm these days, and we have to address that. So as Atasi said, soil nailing, replacing some of the pylons, sometimes even opening the RE wall and reconstructing a part of it. So that's all. Those are things which we have to do. Then not only the RE walls, but even the structures quality has also gone down. So when we acquire some assets, we see sometimes bearings in the shape. You can see the pictures around. So we have to replace the bearings. Sometimes we have to replace suspension joints, and sometimes people even there are years together that some structure has been constructed, bearings have been installed, but those bearings have never been unlocked. So during construction they were locked, so and it is still which is resulting into some shear cracking on the girders. So those we have to address. Then another thing is the concrete quality issues. So we see a lot of honeycombing, voids, poor compaction issues. Lesser concrete strength even. So sometimes we have to do epoxy grouting or cementous grouting, or sometimes even cement fiber reinforced polymer laminates we have to use for the strengthening of the concrete. So these are a couple of challenges which we keep seeing. This is one major challenge. So we talk a lot about drainage, but somehow which is lacking in most of our assets, especially in urban areas. And then you see why it's lacking. So sometimes when we acquire asset, we don't find any disposal point. Where do we dispose of this water? Because there is no integrated plan of a city to handle the drainage system. So highways authority or as a highway operator, we can't do much on this. If there is no drainage system of the city and the road is becoming a natural channel, so what do roads authority, how do they handle this? Sometimes even we see so many people have connected their sewers to our drains because there is no sewerage system. So for that, unplanned development is also one reason for this, and another is that so we are somewhere lagging behind on the infrastructure development, or development of the population is rising, so much of urbanization is happening, but we are lagging behind on the development of the basic infrastructure. Another thing is sometimes drains are there, disposal point is there, but the drains are inadequate. Why? So again, the unplanned development is one reason, or sometimes we have not designed the drains properly. So when I say unplanned development, because what's happening is like so we have designed drain for something, but then the land use has changed. So the runoff which earlier should have maybe like 70%, 80% is infiltrating the ground, and 20% is only runoff, but now it's changed probably reverse. So it's 80% is now runoff. So the drains will become inadequate, and at certain locations, subsurface drainage is not there. Why? Because the road level have increased, or the road has not been designed to take care of that. So these are the things, and then so what we do is like so we try to fix the problems wherever we can. So one of the things what we have done on Delhi Agra road is like we didn't find any disposal point, then we went ahead with the crosswind technology based rainwater harvesting pits, because constructing a normal RWH pit, the problem was that people will throw garbage into it and it will get filled and it will not work. So we had to make some rainwater system which continues working. So we had gone ahead with this type of system. Sometimes we improve wherever we can get some disposal point, we construct drains, and if nothing works, then pumping stations, and pumping is the only way of which we have to go ahead.
Maybe 2
So
minutes.
how do we address these issues in long term? So to me, if you ask me, there has to be the approach has to be now the data driven, and we need to have our assets digital in the digital forms, right from concept stage till the operation and maintenance stage. So BIM, which is now happening across the globe, I feel that we are lagging behind on this, and it's a high time that we have to start working on BIM implementation on our road infrastructure, because we have already constructed significant amount of road infrastructure and we don't have the complete data of our infrastructure. So we need to start working on that. Because only way to make the system work is using data. We have to reduce the human intervention. Every stakeholder has to be on the one platform. So single data people are working on. So when I talk about BIM, so it's basically when you work on the concept, so creating the 3D model at that stage itself, and then keep on upgrading it as the project progresses. And then so that's the design consultants will work on the same model, NHEA also gives approval on the same model, and then the people who are reviewing it, proof consultants, they also give their comments on the same model, and the contractor also works on the same model. And once the project is completed, that model is also used by people like us for the asset management.
Cover in 2 minutes, please. 2 minutes.
So that will transform into asset information model, and so I think that's the only way we have to work on. So I will leave to the other points. I think the construction automation has already been talked about, and new materials have already been talked about. So I'll just close with this. So my main point is like our approach has to be data driven. So we have to create digital twins and use it right from cradle to grave philosophy. So from concept stage to operation stage. Thank you.
Thank you, Bhavin. I think all the 4 panelists have done full justice to this particular presentation, and so I think now we can have a couple of questions, because already time is running out, but still, if you have some questions, or lunchtime also, all will be available. Yes.
गुड आफ्टरनून सर. मेरा CRR मेरे लैब में क्वेश्चन है. रेडमड हम यूटिलाइज कर सकते थे रेडमड एम्बेडमेंट में?
रेडमड का ट्रायल इट्स गोइंग ऑन इन ओडिशा नियर रायगढ़. सो वी आर वर्किंग. इट कैन बी यूज्ड इन एम्बेडमेंट. Raigad case study here, maybe you can approach us directly. So we can share details of that particular project.
And also this is also Raipur Visakhapatnam Greenfield Highway.
Okay.
Sir,
Yes, please.
may I, sir?
एक मिनट पे हाँ। अच्छा आप बताइए चले जैन साहब
Sir, my question is to all the panelists put together. The problem before the country in respect of maintenance of quality of riding or ride quality in case of concrete pavements is a very serious issue. Some milling has been done that is quite costly. Apart from that, it gives the texturing in the longitudinal direction. Whereas when I was writing IRC 15, I had said it is preferable to have transfers because our country has a lot of this dhool mitti during this, and during the rainy season, every channel acts to drain it and we get a fine. This is one problem. Second problem is when we mill it, the surface texture becomes quite, the nodules come out. How to treat that? And then third problem is, apart from cost, supposing to which depth we have to mill. I have done this in 2018, a project which is quite successful, 40 mm, but then it failed. We went up to 100 mm. These are the relevant questions because I have inspected about 50 projects of NHEA. The major problem with the is compaction. I will be dealing it in some forum separately that needs a lot of time. But if any one of you can solve it or reply, because we have to work on it. It is very serious issue. For flexible, we can put some this thing, but for this choice is not available to us in rigid payment. Thank you, sir.
Okay, Tasi would like to.
Sir, I would like to say, as I said, that compaction part is there and intelligent compaction should be brought in. And we are trying to go for intelligent compaction, but again, the layer by layer compaction needs time. I mean, I have shown in like when we are building an embankment, sir. So our embankment is compacted to 95% compaction. So we are leaving 5% there already. That is going to settle. And then if it is built on like, if it is built in like 12 layers, so 250 mm for a 6 meter height embankment is already built in there. So the ideal for, we should go for 100% compaction in those cases to ensure that we do not leave any tolerable settlement within the embankment, and that will only solve the case, sir. Going for 100% compaction instead of 95% compaction.
But that, Tasi, that can happen only when you do not 97%, which is table 300.2, page 66 MORTS specification, right hand corner. That is why I introduced the term compactable density. And in the new specifications, DG Saab was there. When we now you will find like DLC and PQC, we will have trial stretch of soil and to which density it can be compacted. We don't have provision for rolling up to the last. You see any moisture density curve, where is 97%? It is says not less than. We have not gone to the maximum. Few projects which I have investigated, this is the problem, this is very serious. Tasi, we cannot do, we can do it in future.
Yes.
When,
I think with your experience and with our all experience, we should try to address all the issues on concrete pavement especially.
Yes,
You have raised the right issues, and I think any more, you want to have any other comment?
Sir, he has some solution. He has done in
Okay.
See, basically, we have developed diamond grinding for Indian Air Force long back in 2012, and we did Srinagar runway also. but due to the problem is when the production of that tool, we made a drum type tool with diamond grinding bits, and we tried to implement it. The machine was powered by 13 HP diesel engine, and yeah, around 10,000 square meters of work took around 45 days in Srinagar, and it is still functioning.
Okay, good.
Sir,
I think the time is running out. So
I will work with him. We are further developing it and bring out something
Sure.
cheaper
okay.
and also lasting. Thank you, sir.
Okay, thank you. I think we already crossed. Everybody is waiting for lunch.
Thank you very much, sir. And if there are more questions, they could be taken up later.
Lunchtime also you can discuss with any of the panelists. Any question. Most welcome.
So, ladies and gentlemen, thank you very much for joining us here. And let's give a big round of applause to the wonderful, eminent panel that we had here on the day. Thank you very much for sharing your perspectives. Thank you, speakers, for gracing us with your presence right here. We request all the participants to kindly join us for lunch now. And we do have 2 panel discussions and sum up of the session after we return from the lunch break. So kindly please join for the rejuvenating lunch break. And 2:30 we are reassembling and reconvening here in this hall. सभी से निवेदन है 2:30 बजे 2:30 पर हम सभी को वापस आना है जो हमारे बाकी के डिस्कशंस हैं उनके लिए, तो काइंडली प्लीज 2:30 बजे तक 2:30 पर सभी को लौट कर आना है. लेडीज एंड जेंटलमैन, काइंडली प्लीज प्रोसीड फॉर लंच एंड रीअसेंबल एट 2:30 प्लीज. थैंक यू.
सड़क सुरक्षा की पाठशाला क से